Hello everyone and welcome back. So today we're going to talk about serverless web application. So let's say that you have a Lambda and you want to have it exposed to some kind of HTML, JavaScript that you want to put a website on and call the Lambda. So we're going to use the API gateway to do that. So let's say that this is the architecture we want to have this deployed. So we have a user that's going to call some HTML and JavaScript. This is going to be hosted in AWS S3. And then this JavaScript is going to call Amazon API Gateway. And this API Gateway is going to be the bridge to actually talk to your Lambda. So you have to implement your Lambda and then expect the input from a GET or a POST from your JavaScript, and then process this input, do some kind of logic and return it, and then the JavaScript in your HTML will handle the response and then display it in the HTML page. So the technology that we're going to use is, first of all, let's do everything in Terraform. So let's not use the AWS Console, because if you want to deploy like different environments, and it's going to be a pain to use AWS Console to replicate all those changes. So Terraform is a very nice automated deployment technology that you can use. So we're going to do everything in Terraform. And then of course we're going to have to create our Lambda to handle the post and get requests from our HTML JavaScript. And we're going to implement that in GoLang. We're going to set the API gateway to process a GET and POST request and bypass those information into your Lambda. The static, not very static because we're going to have JavaScript in there, but your static hosting will be in S3, and this is where it's going to be your HTML and JavaScript. And of course we're going to use the HTML JavaScript to do the front end to the user. So I created here a POC for API gateway. I have my source folder. I created just an empty HTML that I'm going to show you soon, and my lambda.go. So let's start with the Lambda. First thing you need to do is, because we're expecting a request from API gateway, there is a nice struct or API from AWS that's your request when you're using the API gateway proxy. So let's use that object that makes our life easier. So you're going to use that as a request input. So first thing, let's just log some of those properties inside the request. So inside the request we have the HTTP method, we have the body in case if it's a post, and we have a query string in case if it's a GET. Let's just log everything. Now let's assume that we're going to have a first name and last name as the input for both cases of GET and POST. So let's create those variables. And in case it's a GET, we're going to read it from the query string parameters. And in case it's a POST, we can just read it from the body. But to read it from the body, the way we're going to send it is just a JSON string, so you're going to have to unmarshal it into a JSON first. So to do that, let's just create a struct that's going to handle the first name and last name. Okay, so this is a simple struct with first name and last name. That's the parameters we're expecting. Now let's create an instance of this struct and then unmarshal it from the request body. And now I can read the first name and last name. And of course I forgot to import the request for the API gateway. So here they are, the Lambda one and the events for the request. Now that I have read my first name and last name, let's create the response. Let's just do a message saying hello from Lambda, and then let's put the name as a concatenation between first name and last name. So we're not going to do any business logic here. It's up to you to whatever you need to do it later. So now let's just return the response. So because this will be an HTTP response, we need to return exactly what the HTTP is expecting. So we need to set the headers, the body, and the code. So there is a struct already for based on your events, and we can use that. You don't have to create a new one. So this is the events from AWS, which is the API Gateway Proxy response. We just need to set the body or whatever return you want. In our case, will be a JSON, and then the status code will be 200, and we need to define some headers. So the problem is when we're using the API gateway, we're hosting the HTML and JavaScript in a different location as where the Lambda is. So we need to define some headers in order to bypass the CORS, which is the cross something. CORS, cross origin request sharing. And to do that, you need to add these headers here, saying that we're going to allow origin from anywhere, and the methods allowed will be post and get, and I also added the option in here, and also I'm adding the content type in my information here. So this is very important, otherwise if you do it your JavaScript, you're just going to receive an error from your CORS, which is the security inside your browser, and we're going to use that in the browser because we're using HTML and JavaScript. So this is my response. So my body is basically this message here, which there's nothing special about it, and then the header is the one that has to be taken care of. So Lambda is pretty simple. It just needs a little trick here and there in order to make sure it works. So it's very important to set the headers, and it's very important to use these objects here to read the different cases when it's a get and a post. So let's try to compile this Lambda and see if it works. So same in the way we used before, let's just compile it. I'm putting the object in my target folder, and this is the lambda.go that I just created. Okay, sounds good. Compilation, no issues. Let's now just create the HTML page. So going back to the HTML page, so this is an empty HTML that I have created before. So basically it's just the first name and last name as we were expecting from our inside our Lambda. I created both parameters in here, and then I create two buttons, one to send the GET request and one to send the POST request. So this will call this JavaScript, so let's just create those JavaScript functions. Okay, send the GET request would be very easy. Let's just clear the response. So I have the response here, which is my text area, then I'm gonna put the response. So I'm gonna keep it blank for now, so in case there is some previous data. So I'm gonna call another method that I'm gonna create, which is the HTTP GET. So basically it will be the API URL, I'm gonna call it, and then I'm gonna add the parameter for first name, and I'm gonna read it from here, and then I'm gonna do another parameter called the last name, and I'm gonna read it from this other input. So let's create the HTTP GET now. Okay, let's just log the URL that we're using just for debug purpose, and we're gonna use the XML HTTP request. We're gonna open a new GET with this URL, and then we're gonna send the data, and there's no data to send because this is just a GET request. And then on load, we're gonna process the response, and to process the response, let's just update the text area at the end with whatever we received. So let's log it. If it's 200, we just log whatever the response is, and then we're gonna update our internal text area response ID, and then we're gonna put the JSON that we received in there. So the thing I'm doing here, I'm just parsing the request response that comes from the Lambda, and then I'm just making it a little bit more beautiful with two spaces to separate and align them. Okay, so now let's do the post. So for the post, it's a little bit more complicated. So we need to get, so same thing, we need to clear the response, and then this is the data that we're gonna send. So I'm gonna construct this object in here, which is gonna be my first name and last name, and this is an object. And then I'm converting it to a string before I'm sending the data. I'm logging everything that I'm posting, so the URL and the data that I'm passing, and then just create the same object, HTML HTTP request, and then I open a post with that URL, and then on my onload I'm gonna process the request same way I process the GET. I'm just calling the same method, and then I'm sending the data. And this should be everything that I need to do for my HTML page. So now let's go to the Terraform and create the Terraform to deploy all the components that we need, and then we can test this. So this is my Terraform file. It's a blank Terraform. Let's just create it together. So first thing we need to do is to create a Lambda and then push the Lambda into AWS, because it's going to reference the Lambda when we do the API gateway. So before we do the Lambda, let's just do some trick here. Let's do the compilation of the Lambda inside our Terraform. So every time we run the Terraform, it already compiles in case you forget. So it's a nice thing to have, just an idea that I had recently. So we can just compile the code. This is how you can do it. So there is a resource called just null resource that you can run any command locally, and because I'm on Mac, this is how I'm compiling the code. Remember to update the location of your files, because now we are inside Terraform, and then we have to go back to one folder in order to access the Lambda and the target file. And instead of zipping the file manually, I'm going to zip it here as well. So we can do that using Terraform. You can just zip the file. So this is my target file, my binary after compilation. And I'm zipping just this file. And this is my output path. Now let's define the Lambda. So this is just remembering, this is how you can put the Lambda and push it to AWS. So your function name, whatever name you want. Your handler is basically your binary. Runtime will be go 1.x. Role, you have to put the ARN of your role here later. And then I also upgraded my Terraform. I'm using the latest one right now, so I'm going to use a different way to reference those files. So we don't need to use those extrapolation, which is kind of duplicated. So we're going to use this way now. So just access your data and your archive file, zip, and then my output path, which is this reference here. And then for the source code hash, same thing, the zip file, and we have this property here, and the memory size timeout. And also we need to set the permission for this Lambda in order to be triggered by the API gateway. And this is how you can do it. So your statement ID is allow API gateway invocation. Action will be to invoke your function, and your function will be this. And that's it for my Lambda. So now let's do the magic of the API gateway. And because we're using the API gateway to do a REST call, so first thing we need to do is to create the API gateway REST call itself. So resource API gateway REST API, whatever name you want for it. Just give it a name. This will be in the definition. So after we execute and deploy everything, we're going to go back to the console just to make sure that all the resources are there, our Lambda and our definition in your API gateway. The types needs to be regional for this case. Now that we have our API gateway created, we need to create a resource inside our API gateway. And let's call it just person, because we're sending first name and last name. So API gateway resource person is the name, and my path also when it constructs the URL to access that Lambda. And you need to reference the ID of your API of your REST API ID in your parent which is the root resource ID. Now that we have the resource created, let's create the post definition to access that resource. AWS API Gateway method, and then I'm just calling it post, and the HTTP method will be post, authorization none, API required false, and then you need to reference the API ID, REST API ID, and your resource ID that you just created. So this will be a post to this resource inside this API gateway. And this post, what it needs to do is it needs to trigger the lambda that we just created. So this integration here is going to integrate your post method with your lambda that you just created. So API gateway integration, I'm just going to call it integration, REST API ID, this is what I need, same as before, resource ID, same as before, HTTP method of my gateway method, which is the post, integration HTTP method post, and this type here, this is very important. This is where we are setting to use the AWS proxy. So remember that when we were in the Lambda, we were using the API Gateway proxy. So this will help receive the parameters from the GET and POST using this proxy. So this is very important to set the type as the AWS proxy for our case. And the URI is going to be the URI ARN to invoke the Lambda. So this will come from the Lambda that you just created, Flavio Test API Gateway, Flavio Test API Gateway, and then there is invoke ARN, and this is what we need to set in this URI here. So this is everything we need to do for the post, and now let's just set the GET. So for the GET, it's very similar to the post. We just need to define the gateway method, and we're defining the gateway method same as the post, and I'm calling it GET. I'm setting it here. Let me just update those ones here. HTTP method, now I'm using GET instead of POST, and then no authorization and no API key required. And the same as the POST, I need to do the integration for it. So I'm integrating the GET. I'm calling just integration GET. I need to update those variables. And then, not sure why I need to set the integration as POST, but this is how I've done it in the past and it works. So let's keep this way. And the type, of course, needs to be AWS proxy, and the URI is the same URI of our Lambda, because our Lambda is handling both GET and POST. We could point it to a different Lambda here if we want. Okay, this is everything we need to do to create the API gateway and define the integration between the request and the Lambda. And now the only thing that, the last thing that we need to do is to deploy that, because once you create it, you can deploy it to multiple environments, and then we need to deploy this API gateway in here. So let's just define the deployment part. And based on the documentation from Terraform, you need to define your gateway deployment. I just call it deployment 1. I need to reference my REST API ID. And the trigger, this is important because in case you need to redeploy it, which normally you don't need to redeploy if you just update the Lambda. It's just more for configuration, but in case something changes in your the whole body of, let's say, my API gateway, if I change any structure in here, then it's going to trigger the redeployment. But if that happens, you can also do Terraform destroy and then do Terraform apply again to recreate. But just for to make it easier, it triggers the redeployment based on this condition in here. I also added the dependence on the integration, of my gateway integration, and lifecycle create before destroy. And for the stage, I just call it dev, which is the variable that I've created before, which is my profile. It's going to be dev01. This is going to be the name of the stage. So the name of the stage is going to be part of the URL after the deployment. So let's also update those variables here to remove that warning from Terraform. And this should be all you need to do for the deployment part. But once it deploys, you don't know exactly what is the URL unless you go to the console. So let's just print out the URL from here, because we can actually know the URL based on all the information that's in here. So let's output what is my invoke ARN, the stage name, and the path part that I got from the resource. And this is all the information, this is all the three parts that's going to construct the URL. And just to make it easier, let's just build the whole URL in here based on those information. So you're going to have a nice full path showed after you run the Terraform. So it's just basically the invoke URL concatenated with the stage name / what is your path for your resource, which is person in our case. So this should be everything for the Terraform. So now let's just go back to our shell script and try to run and deploy this thing. Let's go to Terraform and then let's do Terraform. So this is the version I'm using right now. So this is the latest that I downloaded recently. So let's just gonna use this one and do init, Terraform init. So now let's do the Terraform apply. So it added 11 resources. So this is the output that I created. So this is the invocation URL. So this will be the URL that we need to put back in our HTML. And this is the URL that's going to be used for both post and get. And let's just update it right now. So my URL is in here. Now let's go to AWS Console and make sure that the API gateway and the Lambda was created fine. My AWS Console, let's check the API gateway and see if everything was created fine. Yes, test live API gateway, that's the name of it. The ID, it's auto-generated. So it generated this ID here, which is part of the URL, if you notice. Yeah, and then this is the name of your stage. And this is the name of your resource. So let's go inside. Protocol is REST, endpoint, regional, as we created in our Terraform. So as you can see here, this is the person resource that we created, and we added two methods, the get and the post. So the get is lambda proxy integration. It's going to end up in my lambda. So let's click in here, lambda function, use lambda proxy integration, name of your lambda. And if you click on post, it's basically the same configuration, use the lambda proxy, ends up in the same lambda, and it's in here. If you click here on stages, this is the name of the stage that we created for the deployment. If you expand this, we have deployed the person resource with the get and post. So if you click here in the get and post, you can also see the invocation URL, which is exactly the one that we built from Terraform. So just in case you want to double check that is correct and you didn't miss anything. Alright, so let's just check our lambda is created properly. So yes, Flavio test API gateway. Configuration is in here. It's a GoLang and the handler is the name of our binary. Now let's open the HTML page. You can open it locally, or you can open it in S3. We're gonna do the S3 later. So right now I'm just opening locally. This is first name, last name. Let's say I'm gonna do John Smith, and then I'm gonna send the I'm gonna do a get request. So I'm logging here. This is the URL that I called. I constructed it. First name equals John, last name Smith. This is the log object, and this is what's returned. Hello from Lambda, and then I concatenated first name and last name. And this was a get request. So now let's do Adam family and do a post on this one. So it returns the same object, same structure of the object, concatenating those two. And if you see here from the logs, it posts this, and this is the object that returned. So everything looks good, our Lambda is good. So now let's go to S3 in our console, create an S3 bucket, put the HTML page in there, and open from there instead of opening from our local file. S3. Let's create a new bucket. Flavio, API, gateway. I'm gonna leave it everything as default. Create bucket. Let's create a folder in here. Home. Put home here. Let's upload the index HTML. Index HTML, upload, and of course if you have JavaScript files, CSS, image, you just upload all of them. Okay. Uploading successful. So here's my file. If I try to open it, it's not going to work. Access denied. So what you can do is go to your properties, permissions of your bucket, your properties, here, static web hosting. Edit this part, enable, host a static website, yes. Index HTML here. Go to permissions. This is all blocked right now. You need to change that. Don't block anything, because this will be open to public. Okay. Let's try again. Nope, still doesn't work. So let's do this. Click here. Actions. Make public. Make public. That's it. Let's try again. There we go. Now it works. John Smith. Get works fine. Post works fine. And this is how you can host your HTML page in an S3 bucket. Just make sure that you change those permissions and make it public. But of course, make sure that you don't have anything sensitive in there, because now it's open to the public. and the JavaScript is the one that is going to do the bridge and call the API gateway. So thank you very much for watching this, and see you next time.